So if you want to learn how light works, here you go. This is a protein. UV light hits it. That is a light antenna. It's surrounded by water. Light is an electromagnetic wave that changes to an electromechanical wave. That's called sound. That sound is collected in water. Now, here's the interesting thing. Water is a magnetic dipole. What does that mean? Hydrogen and oxygens, positive and negative. That's the reason why it's tied to magnetism. The first time that we found out that magnetism truly controls sound, Ohio State University Acoustic Phonons 2014. You can look it up. When the light hits here, it's absorbed in the water. That changes the hydrogen bonding networks. What is the physical change? The physical change is the density of the water. That is how this works. Fundamentally, quantum mechanically. Now, here's the interesting thing. Mitochondria makes the cytosolic water that surrounds all the things in the cytosol, including the nucleus and the mitochondria. Where is this connection? Well, for those of you who don't know, the Schumann resonance comes from the interaction of sunlight on the ionosphere of the Earth. That's why people call it the heartbeat of Earth. But it's an electrical tension that develops between the solar plasma and the atmosphere that generates the 7.83 hertz. Why do you need to know about it? What I tell you my day job was, I'm a neurosurgeon, right? The alpha wave in the human brain is 7.83 hertz, exactly the same. So guess what? The solar system entrains you to these solar systems as it comes to Earth. That's how it works, okay? Why is it important? It generates the alpha wave. So when you live in an environment today, you don't have as many alpha waves. Why? Because non-native EMF, what's the number one effect, which you'll learn about later, dehydrates your cells because it lowers your redox potential in your mitochondria. In other words, original slide, you can't make as much water from your own mitochondria. That's where the dehydration comes. And for the ladies in the room or the guys in the room who are not big science people, simple biohack at home, take a piece of steak that you have left over, throw it in the microwave, taste it. What does it taste like? Shoe leather. Why? What do microwaves do? They vibrate and rotate water really fast. It heats up and it dehydrates the meat. It's happening to you right now here in Vermont. It's happening to all of us because of these shitty lights that we have. Getting back to the topic, the eye, the SCN is the big focus. In medicine, the big focus is on the camera. That's why all these old people go see the ophthalmologist, and what do they get? Cataract surgery, right? Anybody know what they put in for cataract surgery after it's done? An implantable lens. And guess what that lens blocks? UVA, UVB, 100%, and also, these days, 50% of blue light, in case you didn't know that. That's been a change since 2009. What people don't realize, 42% of sunlight that falls to Earth is infrared A light. It's balanced all the time by blue, okay? Especially when the sun rises. Now, this is a side picture of an eyeball. What you need to know, and this goes back to physics, in case you don't, blue light bends the most by gravitational lensing. It turns out this is important in the eye because when blue light comes through, it falls in front of the retina. That's the reason why when you use a computer screen or you use these horrible lights up here, you get visual obscuration. In other words, your vision gets worse. What does that cause? It causes you elongation of your eyeball. When your eyeball gets longer, you get myopia. What happens when you get myopia? The next step is you get retinal detachments. What's the end result? Acute macular degeneration. Anybody know anybody who's got that? Yeah, lots of people. And guess what else? Guess what causes cataracts? Blue light toxicity. Why? The brain is trying to protect itself from this light that's coming in, so it makes the lens hazy, so this doesn't happen. But why is it important to a mitochondriac? Well, it turns out in about 2003, 2004, through 2009, we had some really cool researchers that found out there's another opsin in the eye. And that opsin works with the retinal ganglion cells, and that's called melanopsin. Melanopsin is the hormone that runs the central retinal pathways in the eye. And it turns out they're really important at nighttime, and they link to melatonin, but not in the way most people think. The fovea is where the rest of the visual light spectrum fall, and it falls right here. Why? That's acute vision. That's your camera focus. That's what the ophthalmologist all pay attention to. They don't pay attention to this. The only ophthalmologists that do, you're going to hear about later, are the Japanese guys, who are the guys that I talked to 3 months ago. They've been on this way quicker than our American counterparts. But here's the key. I'm going to make a very controversial statement now for many people in this room. Central retinal pathway energizes everything distal to it. So let me explain that to you. It basically turns on your pituitary gland, and it turns on everything distal in the human brain. And I'm going to show you how. This paper, I should say this gentleman, his name is Fritz Hollwich. He was an amazing cat. He was an ophthalmologist in Germany. He was born in the 1920s. He happened to live in a time where we didn't have intraocular lenses. One of the things that he noticed is that when he saw people with cataracts, he would cut the cataract out so they could see. And for those of you who don't know, this is what happened to Vincent van Gogh. You know, when he painted haystacks, the reason why he painted them in all different colors is because when you take a cataract out and you don't put a lens in, you can see UV. In case you didn't know that. So that's the reason why haystacks has all the different shades, because he was able to see it in so many different colors as the light changed. Well, it turns out this doctor actually practiced medicine in a time that we could never recapitulate now. That's why sometimes looking back is a good thing.